All right, well, good.
Good afternoon. It is my distinct pleasure and privilege to welcome you all to our inaugural Minnesota Stormwater Seminar Series. Thank you. No, it's just for the online audience. We have an online audience and we have an in-room audience here. Yes. So this seminar series will bring nationally recognized experts in stormwater runoff, water quality, and green infrastructure to Minnesota to share their wisdom and insights with us so we can continue to push the boundaries of stormwater management here in Minnesota. We're going to start today with a panel discussion, and then our guest speaker will get up and give a seminar following that. To start, I will introduce our panelists, and they will give a brief reaction to our topic today. So I'd like to introduce our first panelist. On the far left, Andrea Hendrickson is the state hydraulics engineer for MnDOT. And Andrea, from your perspective and experience, what's your reaction to extreme rainfall events and weather events?
Okay, first of all, I'm going to step back a little bit. My one thing I wanted to share with the group is that I actually got my master's degree from the lab, from the U, and I worked in this lab many years ago. I think I was working under Heinz Steffen, but it was a wonderful place to work, so I appreciate being back here. One of the things that I was involved in was getting Atlas 14 to replace TP40, but as you know, that is stationary data, not non-stationary data. So it seems that in the recent, I don't know, 15 to 20 years, we've been seeing more intense storms and more frequent large storms as we, try to manage our infrastructure. My background is we've actually been involved in some national research where we're actually looking at climate model output for hydraulic design, which is not complete yet. So unfortunately, I can't share it with you. But I've also been involved in MnDOT looking at vulnerability pilot studies to look at vulnerability of our assets. And also we're doing a resilience climate change to be using as our asset management, some planning of our assets in the future. So some involvement there.
Very good, thank you, Andrea. I'll introduce our next speaker panelist. Elizabeth Stout is the Water Resources Regulatory Manager at the City of Minneapolis Public Works. Liz, what's your reaction to extreme weather events?
Well, working for the City of Minneapolis Public Works, we have a lot of infrastructure. And what we're finding with these extreme events is frankly, we're never going to be able to build our way out of these problems. So one of the challenges is communicating that. We have a public that really demands a lot of immediate action on problems, and sometimes the answer is no. And how do we communicate that with both the public as well as our elected officials?
Very good. Thank you, Liz. Our next panelist is Erin Anderson-Wenz, who's Vice President and Senior Water Resources Engineer at Barr Engineering. Erin, how would you react to this topic of extreme events?
Well, so my company, Barr Engineering Company, is a consulting firm that does a lot of work for municipalities and for watershed districts. We do a lot of flood modeling and flood management projects. And so my reaction to the topic is that it's what we're doing a lot of these days. We've done a lot in the past, but I have seen how that practice has really changed. Liz mentioned that sometimes now we're finding that we can't build our way out of the problems. My role is sometimes to be the bearer of that bad news. We are the ones that are running Atlas 14 through cities that were designed for TP40 and seeing what things look like now. And in some cases, looking at some of the things I designed 15 years ago and how they're holding up or not to these new levels of rainfall. So we have a lot of meetings with folks like Liz and some of you in the audience to talk about what we're seeing in terms of the modeling and to try and adjust to a future that doesn't reflect the past and a future that reflects a lot of uncertainty. So an interesting thing that I've noticed is that in these statistical analyses that I used to rely on to guide how I would design something are sort of falling by the wayside a bit as we look for, well, what actually happened last week and what are we going to do when something else happens 10 days from now? So a bit of a change in approach in how we're trying to communicate and solve some of those problems for our clients.
Very good. Thank you, Erin. And last but not least, our invited speaker, Dr. Bill Hunt, who is the William Neal Reynolds Professor and Extension Specialist at North Carolina State University. Bill, how would you react to this topic of extreme events?
Well, it's a huge deal. And my first thing I want everyone to know is it impacts people. And it impacts a lot more people than I think than what we maybe learned in school. And seeing people lose their homes, seeing people seeing cities turn into islands because of extreme rainfall events, and the shocking magnitude of these rains. Like what we once thought was theoretical, like the probable maximal storm, that it's not a theory anymore. And hopefully my presentation will, I mean, for better or for worse, convey that point. And I really appreciate what Liz said. The hardest thing for me to tell people, I can tell you very easily, but the hardest thing for them to hear is you're not going to build out of this. And you're at a point now where you have to decide where you will actually allow construction to occur. And that for particularly for local politicians who want to bring in tax revenue is going to be a difficult pill to swallow.
That's right. Thank you, Bill. So I'm going to go back to the other end again, and I'm going to say, Andrea, so thinking about all of that, so what we've heard so far, how would you say that MnDOT and MnDOT engineers and professionals are adapting in their roadway projects, giving these changes, these maybe unknown expectations, right, for what we should be thinking about? How are they adjusting?
One of the things that we also are having to deal with is finding outfalls. In our storm drain systems, you are trying to sometimes develop a system that has more storm drain that's going to a city that might be undersized. And so we're having to look a little bit further than just designing our little piece. We have to look how it's impacting the other things downstream and how they're impacting us. For instance, something we never used to worry about or do is now we might upsize and design for a larger flood, but we would put in a choker plate to hold back the water until there is an outfall that can actually handle that amount of water. Otherwise, we just move the flooding and the blowing out of catch basins down the system. So we might solve a problem from somebody upstream and it caused another problem downstream. So the other things we do is we've been doing a lot with looking at tools on how to protect our infrastructure. As a matter of fact, there's been several studies we've done in San Antonio Falls to look at embankment protection for overtopping of roadways so that when they do overtop, they don't wash them away. We've also looked at something called matrix riprap, which it helps stabilize under higher flow. So we're looking at or soil nailing to try to stabilize some of these slopes. So we recognize that we're going to have overtopping more often. We just don't want to lose our infrastructure. So we're looking at ways to adapt our infrastructure and protect it when these bigger events happen.
Right, so kind of planning for these, right?
Yeah,
and
it's going to happen.
Management, essentially, right?
Yep.
Trying to protect against and reduce the risk as best we can. So Liz, with your background in both the city of Minnetonka and Minneapolis, you had to deal with this in several ways. What do you think are the biggest challenges facing cities in this regard to extreme events, stormwater management, and infrastructure?
Well, I think one of the biggest challenges is, as Erin mentioned, doing modeling. For example, our Hennepin County FEMA maps are approximately 15 years out of date. They're still based on TP40 data, and that's where a lot of our development decisions right now are being made. So we're not using current data to really look at development patterns. So looking at the newest modeling and trying to make decisions based on that. I think when we've looked at flood control projects in the past, they've really been complaint-based. And we're trying to move away from that because you look at the type of people who complain. They are people who expect a response from cities. So maybe you have renter communities or you have communities of color, immigrant communities. They aren't going to be complaining to the city and maybe their needs haven't been met in the past. So what we're using modeling for is to make sure that we're really trying to be more equitable across the city when looking at designing projects. I think those are kind of some of the bigger ways that we've had to adapt. but also keeping up with maintenance. We have older systems, so making sure that what we're doing is keeping those existing systems functioning for the long term, and making sure that we're investing our dollars where we need to keep those systems functioning.
Very good. Thank you, Liz. So Erin, from working from a consulting background, right, and representing clients, and so how are you and your colleagues at Barr adjusting your engineering for clients in these situations?
Well, I think it's an important time for engineers to try and up their game in terms of using technology and data in a more sophisticated way than maybe we have in the past. We have great tools to watch the weather. We have tools that can watch the weather and make structures move and open, and we can move water a little more interactively. And I think that's something that we should be exploring as options for ways to manage systems that are already built and can't be upsized, for example. So I think it's an important time for thinking out of the box. It's also a really important time to be a good communicator, because as Bill said, this is a topic that affects people. And in some cases, people are affected and their homes are flooded and they lose their homes. In other situations, they think they might lose their home. They think they might have an impact when they actually don't. And so there's a piece of patience and communication with the public in terms of explaining what's happening and what could happen and what's likely not to happen. And I think that's not always something that engineers are particularly good at. And I think in this day and age with the pressures that we're seeing, it's important for us to take that very seriously and to explain what we know in terms that are understandable, and also explain what we don't know. And engineers don't like to do that. But I think that's important as well, because this is a time of a lot of uncertainty. So, yeah.
That's great, Erin. Thank you. So maybe to kind of push a little bit on that too, do you feel like you're getting, do you feel like it's coming from the cities to try to do some of these adaptations, or is it more from you pushing the other direction and saying, you know, we really need to start thinking about this and expanding how we do this or do it differently?
I don't know. I think it's just, I think sometimes a client will come with an idea of something to do. Sometimes we'll go to a conference and see something someone else is doing. I mean, I think everyone's kind of in this together. And I think being aware of how other people are handling these problems, I think things like this are important. Getting perspective from other parts of the country are important. So I think we're all experiencing this firsthand, and it's changing all the time. So being aware of what others are doing, I think, is important.
So it's really the road's kind of going both ways.
Yeah,
All kind of
yeah, I
working
would
together
say,
and trying to,
yeah.
to try to improve.
Collaboration is very important. That's what
Yeah,
I'm wanting to
yeah.
say. Yeah.
So do you think, so I know I've heard it several times, communication. Do you think that's a primary barrier? Or are there other barriers that are kind of holding us back from being able to make big changes in this area? Maybe we'll start with Bill on that.
I think there are. Well, I'd love the communication comment. That is a big deal. And engineers, how many of you guys are engineers, but show of hands? You know, the extrovert engineer is the one who looks at your shoes when he talks or she talks rather than his own. I think the huge barrier that we are seeing in North Carolina is that for a lot of us, the land that floods is near water, and water has high property value. And so, you know, the question is if you're going to make some difficult decisions and say you're not going to be allowed to build here, you're basically taking what was, from a real estate standpoint, potentially very expensive real estate, and you're now taking it off the market. And I hopefully you guys can connect those dots from there. That is a huge challenge that I can already see, even though we just experienced 2 feet of rain.
Any of the other panelists, are there other barriers that we feel are holding us back from adapting and changing and maybe getting to where we want to be in this area of extreme events and infrastructure?
One of the things that is from an engineering perspective, where everybody wants some scientifically based results, that there's a couple of ways of looking at these extreme events, and a lot of them are kind of fuzzy black boxish, and they're not based on the science. And when you get the climate scientists in the room, sometimes they kind of go away from using the climate models to actually do your designs. because they want it peer reviewed and go through like a lot of steps. And so in some respects, the engineers are looking for something that is defendable, and because of the uncertainty in the models, and they come out with these big wide ranges, they're really not set up for giving you a design event. And so it means that we're going to have to totally change the way we look at design, from going from just a single event. We're going to have to, maybe you design for a single event, but you have to look at things over a range for vulnerability or something like that. So we're still using rational equations from 100 years ago. So this could be a huge change in the way we actually do designs, and that's a barrier. We're going to work through it, but it's going to be a lot of work.
Well, and as Bill mentioned about, waterfront property having more value, it's less of an issue in Minneapolis since all of the lakes are publicly owned by the park board. However, a lot of suburban communities, for example, Minnetonka, where I used to work, had 13 lakes and approximately 1,000 wetlands. And really all of those are in private hands. There isn't the type of park board that there is in the Minneapolis area. So what you see is there is actually a lot of system capacity to absorb some of those really high volume events. But what you have is you have yard flooding. We didn't have a problem with structural flooding, but you have people that now their landscaping is underwater, or their property is being impacted even if their structure isn't. So they want us to design so that they're really living next to a swimming pool to an extent, rather than a natural system that we could then utilize for some flood protection. So that's definitely a barrier to get over for a lot of suburban communities.
Andrea's point, I think, is absolutely spot. I was sitting with an engineer yesterday in North Carolina, and I could tell you who it was, and it wouldn't matter if you don't know him. But it's a classic case of how traditional engineer operates. He was telling me, he's like, you give me the rules, I'll build to the rules. All right. And I was trying to say, you might not want to hear what I have to say, because I'm saying that I don't think the storms are, I don't think that the storms we're designing for are sufficient. I think it's too low. It's too small of a storm event. Give me the rules, I'll build. It's kind of like, I won't go there, but we're very fixed. And I think what the engineering, and I talked to I would say, more enlightened engineer, and his comment was, just give us some new numbers to design to. And I honestly think that is one of the, we'll go to the property owners and tell them, well, these are the new rules we have to design to. And essentially, I think what it does is it takes away a little of the mystery, even though the mystery is still there. We still don't know exactly what's going to happen, what we need to be designing for. But if we can at least adopt more conservative design standards now, engineers, if trained to them, will do it.
So then, that kind of gets to, risk management a little bit, and also liability then, right? Because I mean, if you have strict guidance that you have to follow, if you want to go above that, then you might have to justify that to who's paying for it, right? If that's public money, right? And on the other side, if you just go right to it, then are you liable or not liable? Or if you design outside of the specific guidance. I guess, are there any comments or what's your reaction to that about risk management, liability, and kind of going outside the design? Can we step outside of that box safely?
You want me to start and you guys follow on that one?
Yes.
It is doable on public projects. And I think this is the case where the public sector has got to take the lead. All right. The way private development works, and you guys know this as well as I, is you have a property owner who builds the property, sells parcels, and leaves. Mm-hmm. And it's not in her or his interest typically to start worrying about what might happen 30 years from now, because she or he is gone. They're building the next bit of property. And so I really believe that the start has to be on public property to go above and beyond, which really is not above and beyond. I think that's the main point. It's not above and beyond. It's what things actually are, and we're just doing below and behind right now.
Right. Yeah. Well, and I think maybe that above and beyond, I mean, what I've seen some cities and watersheds doing is the above and beyond isn't necessarily trying to build everything to protect to the current new 100-year Atlas 14 storm, but is to do the best they can, do those projects that make sense, that, you know, maybe have multiple benefits, but then also convene to talk about, okay, where we can't do that, or where we get bigger storms later, because this is a moving target, right? Where can we protect the hospital? Where can we protect the food supply? Where are the evacuation routes? You know, so instead of, you know, and maybe that's one barrier, is I would hate for us to be hung up at perfecting, you know, that again is sort of engineering mindset. Let's get this nailed down. Let's protect to the 100-year everywhere, and then miss the opportunity to think bigger picture. Like what if we get the 500-year event? That could happen. You know, we're not going to build structures necessarily. Maybe there's some places we can do that, but the bigger question is, what happens to our city if that happens? And where are the vulnerable people and the important structures, and how do we protect them? Which is a very different way of thinking about engineering design for cities. But then, you know, and then the important part of that is making sure that the people in the know about the strengths and the vulnerabilities throughout these communities are at the table. So you're there with public health, you're there with emergency management, you're there with public works, you're there with the parks, you're there with, you know, the school district. And everyone together is looking at maps of, well, this is where everything could flood if we get the 500-year. How do we keep that highway open? So that's a different way of thinking about above and beyond. We won't be able to lock this all down, but we can get ideas of where the water is going to go. So.
I think understanding, you know, the consequences of those very large flood events is important. And even for smaller events, you know, understanding perhaps in neighborhoods what the level of service expectation is. You know, we can't contain all of this water. Is street flooding acceptable? We know we have street flooding. Is some level of garage flooding acceptable? If we protect all of these homes, what is setting an appropriate level of service for those neighborhoods and designing to that? We have a lot of, you know, existing infrastructure. And so even if we could upsize, we may be connected to something downstream that doesn't have the capacity. So really understanding all of those challenges and some of those consequences is another really important factor.
Same thing that everybody else said. The biggest thing we've been talking about is the risk and exposure, and trying to look, maybe there will not be one set of rules for everything, but the route, it may not be all roadways, but the route to the hospital might have a different standard or a higher standard that we're designing to. And the other thing we've been talking about, and this has to do with the communication issue, is maybe it is unreasonable if you have a 4-inch per hour rainfall to expect no standing water on your roadway. You know, at some point, the water is so much that the road will be where we're storing it, hopefully, because the other option is to have it go other places. But you know, so it's maybe we have to manage expectations a little bit too. So
I appreciate that.
Yeah, so I think, you know, communication I think is key, and kind of what I'm also hearing is it sounds like we need better collaborations.
Yeah.
You know, because a lot of times we can't go beyond our jurisdictional boundaries. We're kind of confined to that. So what are maybe some ways we can improve on collaboration to be able to think about the bigger picture related to these issues? Do we have any good ideas about that?
Well, it's interesting because I formerly worked for the upstream community of where I work now for 2 different water bodies. So coming from really the highest point in Hennepin County to Minneapolis, which is really the downstream and receiving water, has been interesting to see the consequences of decisions that all the upstream communities are making. I think one of the things that at least the metro area in Minnesota does really well is with watershed management organizations, looking across those political city boundaries to that larger regional scale. And each city has to understand in that framework what decisions they make will impact, you know, the creeks and the lakes downstream of them. I think that's one tool to do that. I think also just having forums like this, having open communication, sitting down and thinking about if you're putting more water into a creek, that is going to have a consequence, and maybe setting up a different regulatory framework to look at that and not just think of your own community or even your own infrastructure, but also that receiving water and what we're going to be doing to those downstream receiving waters and communities.
Collaboration is also important. Like for instance, we were talking about closed basins, and we had a closed basin and it kept flooding as the water rose. We had 2 projects. We kept raising the road because it kept getting overtopped. County came along, and we are confined by our linear system and our right of way. County came along and said, well, why don't we just put in a tile line and we'll tile it to an outlet? And we're kind of like, well, we can't do that. Well, we can give you some money to help you do it. So, I mean, the point is, we collaborated. What we were doing was a temporary fix, which kept needing to be refixed. But when we collaborated with the county, we were able to actually solve the problem more long-term. So, I mean, these collaborations are really going to be important in dealing with more water and more extreme events. So,
I think in terms of another point on collaboration is leveraging people for information. So I've seen great situations where a watershed district will have kind of a master stormwater model, and then they're monitoring, maybe the county is monitoring water levels, and the watershed district is plugging those into the model and then seeing what a future rain event could do, and then communicating that to the cities who are in charge of protecting homes that could be at risk. And I've seen that work really, really well together. And then there's not just one entity that's taxed with all of that. And then that just helps foster more communication about what can be done, outreach to residents and making sure that all those bases are covered. So I think that's important as well, to share information.
My message on collaboration is that it's kind of like having a semester-long project. That when's your semester end, profs here? Middle of May. So does it start in the middle of January? It's kind of like assigning a semester project in January, and the amount of work that happens on that project in January and February. That's the type of collaboration we had until we got 2 feet of rain. And then it was like cramming. And then you're doing your semester project the first week of May, and it's driven by the politicians. And unfortunately, and it may just be North Carolina, Mahunchits, it's not, is that we've done a couple of great things environmentally. They have been in response to catastrophes. And I think what I would love for Minnesota to be able to do is actually be truly ahead of the curve, so that when the big problem happens, you're in a position to truly deal with it. Whereas right now, we're in a very reactionary place. But calamity does cause change. And so I am, as an optimist, I am sort of excited about that. But we had a lot of problems happen for this to occur.
Right, and I think communication, I think collaboration are key to that.
Yeah, absolutely.
Stay ahead and get ahead of the game.
And so I meant to say the politicians that are now involved in this are forcing collaboration and communication.
Right, and so perhaps we can do that internally and work our way up, and help drive it from that direction. I think at this point I'm actually going to turn to the audience now. We actually have a very large online audience. So we're going to field questions both from online and for those of you in the room. Do we have an online question that we can ask at this time?
Yes, we do. So the question asked from online is that the current rules are a reflection of the social contract of what is allowable and what is the palatable amount of risk that people are willing to accept. If there's a revision to the social contract that is needed because the historic balance between cost and benefits is shifting, we should reopen the discussion. And how do we go about reopening that discussion and let people make the value-based decisions and making sure the public isn't paying for private benefits?
There's a lot there.
A lot
That's-
there.
That was a good one. That's 3 questions.
Yes. I do think the social, I appreciate the question very much. And I do think that person got to a key point in all of this, is that we have operated looking backwards on and what is socially acceptable risk. All right. And that's why we have 1 in 25 year, or 1 in 100 year designs that were 1 in 10 year. And now knowing that those numbers probably are not right, at least in North Carolina, they are not right. We need to sort of open it back up again and see what type of risk we are willing to do about that. Unfortunately, I said that's something someone else besides me is going to have to do, because we're maybe some of y'all gifted in that. That is not my bailiwick, but there needs to be a larger discussion of what is okay and what is not.
And that's frankly kind of a bit of a barrier here, because I mean, in a very practical sense, you know, my company helps cities come up with their surface water management plans. And 20 years ago, you wouldn't think twice about seeing, and we'll design the conveyance system to the 10-year event and the flood system, you know, the flood management system to the 100-year. Okay, good to go. Well, now this round, I'm helping one of the cities in the metro with their plan. And that's what, you know, looking at the last plan, that's what it said. And I know they're not doing that right now, because we did the modeling. And I know they don't have the 100-year. So then it's a really interesting discussion. Like, well, what are you going to say? How are you going to explain that? And, you know, they knew they couldn't say we'll protect to the 100-year, because they're not. So then it's careful language about trying to do that. And then also trying to prioritize projects with, you know, public health and looking at vulnerable areas. And it just, the conversation becomes a lot more complicated. And I don't know that we can come to a new number that's the acceptable number. And I don't think that's what the questioner was asking, but that level of what acceptable risk is going to be so site specific and community specific that it's going to be harder to define those things. We need to do that. That needs to happen. And that's engineers and scientists and public, you know, people from cities and watershed districts that will do that. But that's the work that needs to happen.
One thing that I got out of that question was, you know, making sure that the public isn't paying for private benefit. And that was one thing with developments, is do we need to look at tighter development standards? You know, Minneapolis developing here, it's where we don't have a greenfield in sight. So we're looking at really retrofitting and designing things into an already built environment. Do we need to look at tighter standards? But with that, balancing the need for economic development. I think those are some very competing interests, but I don't think that they necessarily have to be fully opposed to each other. But keeping those in mind as we move forward with development and making sure it is done responsibly, that we are not putting, you know, additional burden on the public infrastructure in order to just develop. I think that's long-term in the city's and the public's best interest.
It's a long discussion. I mean, I think, you know, the standards we have right now really are, I've always considered kind of like minimum standards. And there has always been the ability to increase them as needed. So actually a lot of the standards are 50-year design here, but some people go, if 50-year washed out a couple of times, you don't put it back in, you go to a 100-year design or something bigger. Or flood a record is another one that we actually sometimes fall back on as something that we might want to design for. But again, we're not going to be able to build our way out of it. So we're always going to have to be looking at what kind of criteria or guidance you can give. And the one size will not fit all is really resonates with me. And MnDOT is going to be a really hard time to, you know, there's a lot of judgment involved. And until we get more guidance on it, kind of work this through, it's going to be messy.
What other questions do we have from the audience? Randy had his hand up before I finished the question. So please introduce yourself and question.
Sure. I'm Randy Neeprash. I had my hand up 15 minutes ago. So one of the things that we know how to do well is water quantity modeling. And we know how to do what I would call a full system H&H model for, say, an entire city. I was recently in a room full of city engineers and asked how many cities had such models. And a surprisingly small percentage raised their hand. Then I asked how many have adjusted, revised their models since Atlas 14 came along, and it was an even smaller number. Question essentially is it a worthwhile public initiative for, say, a state to provide funding support to incent cities to develop such models, if they have them, revise them, make sure that they have the larger current storm regimes included in the modeling, all with the intent of trying to identify problem areas before they turn into catastrophes for the dozen reasons why that's a good idea. So is that a worthwhile public initiative?
I think that's a job for the watershed districts. Well, I say that a little bit facetiously, but I actually think that to some degree that is more of a regional, that's a really good job for one of the watershed management organizations to look at those, to look at water more regionally rather than look at it just from the city boundaries. You know, as the receiving water at Minneapolis, I mean, we do have a lot of, you know, smaller systems. We do have models, and we're working to, you know, build on those and refine those. But for smaller communities, I think that that is a perfect example of how collaboration works and how we should look at the watershed scale as opposed to just the community scale.
I would say for some cities, I think that would be great if they use the model. I mean, you can have a wonderful model that, you know, is perfect in every way for this moment in time, but not only is precipitation going to change, but also if you don't stay up to date and update it and use it, then, you know, then that's not as useful. I think, and depending in some areas, if you have a lot of landlocked basins or basins that have very small outlets, modeling is helpful, but it still depends on where you start, where that water body starts. And in those situations, I'm starting to think that intensive monitoring might even be more helpful. So I think it depends on where you are. Yeah, I think it depends.
I know in North Carolina, after the big storm, the governor, I'm trying to see how much I want to give away from my presentation. I'm going to sit on some of it. But the governor convened a coastal commission, and that is one of the things, one of the outcomes that is, I would say, somewhere between probable and possible. It's on that 50% that there will be money given to cities so that modeling can be done using revised rainfall expectations or projections to see what. And so I think there will be many communities, not all, but like Erin said, but many communities could really benefit from seeing their homes in blue and their buildings in blue. That has a profound impact on people. That's where I live.
Mm-hmm.
And so I really think that could have some positive effect.
Other questions?
Tom Matheson, actually retired former city engineer, public works director for Crystal. Two things. To the first point for Randy, and actually Randy spoke at our annual city engineer conference in January out at Earl Brown, and we had Mark Seeley there along with Cindy Voigt, who spoke on the Duluth flood. It was a great presentation. And but to Randy's point, I predict, aside from all the modeling, what's going to ultimately happen is that every city is going to take 12 inches of rain, put it on their city over 12 to 24 hours, see where the heck the water goes, and just start clearing a path. Because that's ultimately all we're going to be able to do. You know, 7% more water every degree that the temperature goes up, right? More water vapor in the atmosphere. But aside from that, to me, the real elephant in the room here, to some degree, and I want the panel to reflect on this, is sadly, we're preaching to the choir in this room and most of the people online. We still live in a culture in this country where the deniers are still there, including obviously a president who's very unenlightened, and not only that manner, but so what are you facing when you go to developers, you go to your city council, you go to the county, when you go to the state legislature? You know, we should have started doing this 20 years ago. And I don't know that we're actually going to be able to catch up. Mr. Hunt said that we're really good at reacting to catastrophes, right? And I'm afraid that's what's going to continue to happen for quite a while. You know, we all live in houses built of sticks, and here comes a lot more tornadoes. So I'll get off the mic, and I just wonder, as far as, you know, I know it's changing. You know, the pendulum is swinging just because there's a lot more bad weather and all kinds of other things that are showing that climate change truly is here. But what do you face in your own constituency about that problem, and saying, look, we've got to design for the 500-year event now all the time, or something like that?
I'm gonna start.
Go for it.
We have, it's not a good thing, but we have one advantage, and that it hit. And it was a great story. I did not, this was recounted to me, but it was someone who was, well, I don't know about all that climate change, but I don't want to get flooded again. All right. And whatever it takes so that I don't get flooded again. You know, they may not adopt the moniker, and that's actually part of maybe they won't adopt the term climate change because for numerous reasons, but they don't want to get flooded. And in that regards, I actually see a fair amount of hope, because they know, because now you mentioned the flood of record. I think it was Andrea, you mentioned the flood of record. Now for many communities, there's a new flood of record.
Except that's just for those people that got hit.
It's very true. It's very true. And it basically took the storm and then telling neighbors. So even not everyone in North Carolina was devastated by the big event, though the state in general is reacting. But certainly a storm hitting North Carolina is not going to impact even folks in West Virginia, let alone Minnesota. You know, in terms of the mindset, if we got to change things, they, you know, the folks in West Virginia, unfortunately, have to go through their own horrendous flood for them to make important decisions, right decisions. And I wish that were not the case.
Well, I'm fortunate working for Minneapolis that there is awareness at our political level, our council members and our mayor, about climate change. There's not that immediate reflexive pushback that doesn't exist. I also think that going from, you know, TP 40 to Atlas 14, I mean, that's a reflection of the past, but we are seeing change. That's not in the future, that is now, that is happening now. And I think the argument can then be made is we're going to see future change, and we've already seen it, and here's what the progression may or may not look like. I think the job for staff, and it's really difficult, is then translating that into future action. It's what recommendations do we make based on the knowledge that we have? And, you know, we have to balance a lot of different priorities, but to some degree, that's a political problem. As staff, we need to look at the best available data that we have. We need to, you know, look at our models and look at some of the predictive things, looking at rainfall, and make recommendations. And maybe ultimately the political decision needs to lie with our you know, with our council members. And we just need to make the best recommendations that we can based on the best information that we have.
One of the things with the extreme event, I think you hit it when, well, both of you, when people see it, that gets their attention. After the big floods, both in Duluth and in down in our District 6 Rochester area, where they had a 2,000-year quote unquote storm event, a lot of washouts. Actually, the legislature did create, give us flood bonds to actually do flood mitigation projects. So it's going to be slow, but as these events happen in one place, money might become available. So our legislature turns and changes on a regular basis. So you have to wait till the profile of the legislature is inclusive, but they have reacted in a way to, like I said, after an extreme event, it's recognized and it sort of dies down for a while until a large statewide extreme event or, major events type happening. But at some point they're going to come fast and often enough that it will have to be addressed.
Yeah, I think we use the word resilience a lot with clients. And actually I used to worry a lot more about using the term climate change with clients I didn't know as well. I really think that's changing a lot. But I think the term resilience, whether you're tying it to whose fault it is or not that the climate is changing doesn't really matter. What matters is that we're seeing much wider variations, and I do think more and more people are starting to experience that firsthand, which does unfortunately help advance the cause. Also, I think, I think these problems are being handled on the local level, not on the federal. I mean, that's not always the case. There are some larger scale projects where the federal government gets involved, but it's mayors and council members and city officials and watershed districts who are doing things about this and starting to make decisions. So I find a lot of hope in that as well. There's a lot of power locally because they're the ones experiencing the problems and the ones that are first and foremost answerable to things that aren't functioning. So
I want to say amen to that. We do that in North Carolina. I don't know if y'all do it up here, but I will also point one more thing out. And President Trump carried Texas and he carried North Carolina. He needs to carry both of those again if he wants to win. In 2018, North Carolina had its storm, one of its storms of the century. In 2017, Houston had 40 some odd inches of rain. Those are important constituencies to the person in the Oval Office, voter blocks. And I have been told, though I have not personally gone after them, that in the Department of Homeland Security, there are 7 initiatives, and one of them is extreme rain. And that you can get money. And I know for a fact a town that I'm working with is working with the Department of Homeland Security to get money to basically design up for bigger storm events. It happens to be a very affluent community, and they're sort of wired in, but it's not an impossible thing. I think there's the federal money is there if you know where to go for it. It hasn't been widely advertised. Maybe the community's mad I mentioned it.
it is
I
now.
was gonna say it has now.
Now it has, that's right. To the 7,000 people that are listening online, you're welcome.
Actually, let's take another question from the online audience.
Thank you. The online question was asked, for infrastructure design purposes, should consideration be given to using a downscaled global circulation model or regional circulation model using a scenario such as RCP 8.5 to estimate the 100-year storm rather than relying on NOAA Atlas 14, which is still using hindcasting?
I'll weigh in on that one.
Right.
That's part of a study we were doing. But actually, the interesting thing about Atlas 14 and looking at the variability in the climate models, if you do look at Atlas 14 and look at the 95% confidence intervals, they do pretty much cover the ranges that the model results are getting. So it would be way more accurate to go to the models and look at the higher, like the 8.5 or, type thing. But in push comes to shove, if you're just looking to see what the vulnerability is or, a basic idea of how much water it could be, you could actually start by just looking at I wouldn't necessarily design everything to that higher level. We've already talked about why, but it could be used to look at the vulnerability of an area. So I'd like to go with both of them, but for now, you can just start by looking at the confidence intervals just to get you're just looking for a range.
Yeah. We sometimes look at the 500-year storm event for that same reason. It's kind of a future type of scenario. I mean, frankly, you're just putting a lot into your model and seeing what happens. But there is a basis of that that's tied to Atlas 14. I mean, there's a foundational basis for that. But I mean, yeah, ideally you would be seeing what the climate models are showing and comparing that. Last time I compared, they were similar, but that science is changing all the time as well.
We've used RCP 8.5 for some stormwater control measure design, not to try to mitigate big storms, but to take a look at how this thing will work over the course of a longer period with future climate, how undersized essentially would our practices be based on current design standards. Got a couple of journal articles out if anyone really wants to read about that. But the thing that struck me about it is, one, some of the work, when you look at the RCP 8.5, in some parts of the United States, it gets better. Like they project out. So we could do that, but I'm like, I don't, you know, it gets better. Basically, the practices are working better. When we did some work up in Northern Ohio, they got better. In North Carolina, the practices didn't work as well under the new climate scenario, but the amount of degradation they have was somewhere in the 10% range, all right? The thing that struck me about using it is that you couldn't get those data for everywhere you went. Whereas the Atlas 14 95th confidence interval, if there's a station there, you got, you know, the data is available, the data rather are available. And I could see RCP 8.5 being used at some point in the future, but as of right now, to be fair, it's been a couple of years since I've done that work. I don't think there's enough of those data available for us to make informed decisions. I'd actually probably rather use the confidence interval on Atlas 14, but that is a place where we're going or could go.
And there are some, in the metro area, there are some communities trying to come together to find ways to get that information for engineers and decision makers to use. And I think that's great. I think to do it collaboratively and get tools for us all to use is helpful. It's not a silver bullet, but it's helpful. More information. I mean, we always like that.
So one thing I don't think we've really talked about yet, we've talked about, you know, expecting larger events, trying to design our systems better, maybe having better models to understand how this work as a system as a whole. But all of that assumes that our infrastructure that's in place is intact and functioning as it was designed, right? And our systems, our stormwater treatment management systems, our flood protection systems are all, again, in place and will operate as they were intended or designed or constructed. So a question might be, can we do a better job of inspecting and making sure these things are in place and accurate? Or will that really make a big difference? Or do we really need to just size everything bigger?
Okay. One of the big take homes I got from that climate, the future rainfall pattern study that we did, was that maintenance was more important than what the climate's going to be. They're not, it's not like it overwhelms what's going to happen going forward, but the lack of maintenance in terms of how a practice will perform for a nutrient load reduction, for example, is more important than what the climate's going to be in 30 years. Okay. Where I think the maintenance will matter is how systems might perform on those, would say, moderate size event, the 1.1 year return interval, the 2 year return interval. We're not designing practices even remotely close enough, big enough to have an impact on what the potential rainfalls might be. So we either maintain them or not, it really won't matter for a big event. Only on the fringes.
You know, asset management and infrastructure maintenance is critical. We have a lot of aging infrastructure in Minneapolis. A lot of that is, once you put a lot of stress on that system, I think that really can lead to ultimately to more and more failures. We have a really robust inspection system, and understanding the condition of our system and then looking at what are the possible consequences of if it does fail, and trying to look at where we then plan our replacement scheduling based on that. In some other communities like Minnetonka, we put in a lot of corrugated metal pipe, CMP pipe, has a lifespan of about 25 to 30 years, and we put it in about 40 years ago. So that the consequence of that decision making that long time ago means that we have a lot of just infrastructure cost now replacing pipes, where we have roadway collapses and we have sinkholes, and understanding the consequence of the decisions we make today on long-term maintenance. And it might be short-term, a cheaper solution to look at different pipe materials, but what does that mean for the long term? And understanding that our communities are going to be here for not just, the lifespan of, my career for the next 20 years, but, 50 years and 80 years down the line.
One of the things with failures that we actually have noticed is we actually did have noticed a correlation between bad condition. If there's joint separations or holes in the pipe, you put a head on it, it'll pipe and wash out the fill. So there is a correlation between failures and high water tables or high water. But we've also found that a lot of our major failures are when the water gets so high that it goes a different route where it's not supposed to go. One of them was a dam failure. We had a 48-inch pipe and it completely washed out the whole road. This is up on in Duluth. I think people have all seen the pictures with the road completely gone, and it took us like a year to replace it because it was like completely gone. But so a lot of them are related to, or what happens is it skips over. So the water goes up and now it goes over a high point. Now all of a sudden way more water ends up at the culvert below or at the structure below. So, sometimes it's that the water just is completely overwhelming the systems. And I don't know if maintenance is included, but you really that's where stress testing the system to find out where the water goes when I put a ton of it in there, becomes important. But yeah, we think maintenance is, and in managing your assets, you need to know where they are and what condition they're in. And that should help maybe,
Great. So let's take another question from the audience. Who has a question in the audience here locally, if any? How about another online question?
What do you see as prime opportunities to engage the public and empower them to be part of the developing solutions? And if you have part of the public that are concerned about real and present costs to mitigate potential future damages, how do you go about justifying those to them?
Gets back to communication, right? Being able to speak their language and being able to convey the message, right?
Well, I think it comes down to people care about things that they know. So educating them and introducing them to how things are interconnected. I frequently tell the story that I've hired civil engineering interns in the past, and one of the questions we ask is, describe a storm sewer system. And these are very, very smart, usually junior level civil engineering students. And I'm going to tell you a majority of them think it all gets treated at the water treatment plant. So just that basic understanding that, what you, from a water quality standpoint, what you put on your street and what you put on your lawn, that ends up in the pond, the lake, the stream, in your backyard. So that direct impact that the public has on water, I think just getting that message across and getting that understanding out there is really the basic. Having them know their connection to the system and maybe working towards what they can do then are the next steps. First you get to understanding, then maybe you look at, what are the impact or what are the things that they as a community member can do. With flooding, it's a little bit harder. There are less things as opposed to water quality that a resident can do, but that goes to understanding the level of service. Is if a homeowner understands that, we can't send more water down to the creek without causing ecological damage, then maybe they're more accepting of having, roadway flooding that would then, balance that negative impact to the ecological system that maybe they're more connected to.
We'll take one more question here from the audience.
I can't believe with this audience, I get to ask 2 questions. So urbanization causes more runoff and flashier runoff. One of the neat things about more rainfall and more intense storms is that the result is more runoff and flashier runoff. So two identical systems. One way to look at our stormwater regs is that cities are being expected and required to mitigate for the impacts of urbanization. But how do we distinguish between these two different identical signals and avoid, say in the context of numeric TMDL wasteload allocations, trying to hold cities responsible for changes in precipitation? Another easy question.
Right.
Yeah.
Thanks, Randy.
Thanks, Randy.
I am regretful I cannot cite you a study that was done. It was in the Washington, D.C. area. And they looked at the, they basically looked at the role that urbanization played. It was a big meta-analysis. They looked at the role that urbanization played in flooding versus that of projected rainfall patterns, or actually realized rainfall patterns of the first half of this decade, roughly the first half of this decade. It actually stretched back into probably 2009. And the answer is that based upon the rainfall patterns that they observed, urbanization overwhelmed the change in rainfall pattern in terms of what was getting flooded. And if you think about it, that should shock nobody in this room, because when you knock trees over and put a parking lot, paradise, but the parking lot, I mean, you guys remember from your curve number loads or just you know, the arrows up, down, and that it's a 5-10-fold increase in runoff, all right? Whereas we're talking about the changing precipitation pattern, at least what has been projected, not what I'm going to show you later, but what has been projected, you're looking in the margins like 10% more rain. And so that's a 1.1 multiplier versus a 5 to 10 multiplier. The real danger in moderate size storms is not the increment, in my mind, is not the incremental increase in rainfall that we're going to see from moderate size events due to climate change. It's knocking trees down and not being particularly careful about how we try to reapportion the hydrology once we've done that and covered up with parking lot. Urbanization really is the major killer. And honestly, it's good for my business because that's what, you know, it's good for all of us. But the good news is that that is something that is predictable, all right, and can be designed. We could force low impact development to be used. Maybe some Minnesota communities do, all right. North Carolina, it's just a carrot that it makes it a little bit easier to get a development through. All right, that's all it is. But if you force low impact development where you actually try to bring the hydrologic cycle closer to imbalance what it was with the forest, that probably will do more good for you than, you know, designing on the fringe for the increase for the increase in rate associated with moderate events. All right. It's a good question. They all have been good questions.
They have been. I do want to speak about the benefits of urban density. I think that I have to. I work for Minneapolis. I think that increasing development in urban cores, I think that really decreases then that greenfield development where we are getting the actual tree cut down for the parking lot and for the strip mall and for the, you know, half-acre minimum residential lots. I think that's an important thing to think about outside of a stormwater perspective is that goes to, you know, your transportation systems and your carbon footprint. And I think that that's something worthwhile thinking about is the benefits of density in these already established urban cores.
That's a good point.
Yeah. So maybe to close, what I'd like to do is I'd actually like to give our panelists a chance for a couple more minutes of kind of closing thoughts and maybe one or two ideas of what we can take going forward for dealing with this issue. What are kind of the big picture things that you've seen and heard today and what we've talked about in our questions that you want to give our audience as takeaways as part of your closing thoughts. So Andrea, why don't you go ahead and go first since you let us off in the beginning.
Okay.
Thank you.
Well, one thing I think we've all heard is the importance of collaboration and communication, and that one size does not fit all. And my last thought I want to leave with you is at least we don't have to worry about sea level rise.
That's right.
I want to echo what Andrea said about, collaboration and integrating different systems. But I think many of us here today aren't the decision makers. We aren't the people who are, at the policy level, at the, city council level. And what we need to do is be courageous with our recommendations, with what we're telling our elected officials to do, is step outside of our comfort zone and say, this is a problem and here's how we need to work towards fixing it. And actually, stepping up and making those recommendations, even if they are uncomfortable for us.
I would say, well, we're not worried about sea level rise, but in some parts of our communities, we're worried about groundwater level rise. And that's been something that's been eye-opening for me as an engineer, is to remember the complexity of our environments that we're working in, and that, we have changes in precipitation going on. We also have fluctuating groundwater levels, and we're designing systems that sit in between. And so I think keeping eyes and ears open to better understand those systems, to leverage technology, to leverage monitoring data to the extent that we can, to make smart designs that'll last at least a little bit longer. Also, I think it is important that all of us put on the hat of the communicator and to ask for help in communicating if we need it, because these problems do affect people. I started my day with an email forwarded to me by one of my clients from a constituent in her community that is worried about being flooded and said, I'm scared, I don't know what to do, why aren't you doing something? And so now we figure out what to do. And so that social piece can't be forgotten. And especially, we didn't talk about this today, but also trying to factor in when we're thinking about where to put projects, we did kind of talk about it, where people that are vulnerable might not speak up for themselves. And I think that issue of environmental and social justice is an important part of our work as engineers as well.
Those are all great points. And honestly, I think all I'm going to do is echo what you guys have said. I'll be really quick. One of the comments that was brought up, I really like the idea of the social contract being opened back up. We operate looking backwards, and it's time to pivot a little bit, look forward, using some of the newest data we have from behind, and discuss what is acceptable, which basically gets into what Erin talked about, is, communities that are flooding, they may not have spoken up in the past. There's more of a voice now in my mind for communities that had been underrepresented in terms of calling elected officials, which is, I think, a really good thing. And the other thing is, I think going forward, we cannot be afraid, and this is an echo of what Liz said, to step on some toes. Engineers hate stepping on toes. We have to be comfortable with stepping on toes to make decisions that we believe are right, or informing people that can make decisions that we believe are right. I'm going to make a big point of that in about 15 minutes. And the last thing is, Mother Nature wins. It is a very important point, is that you cannot design around everything. You can come up with contingency plans to help make people safe, but there comes a point where Mother Nature wins. And it is a very humbling thing for most engineers and most people probably to accept.
Amen.
Thanks.
Thank you. So if we can, please give our panelists a round of applause.
Good afternoon. My name is Lian Shen. I'm the director of the St. Laboratory. And I just wanted to say a few quick words to welcome you to the lab and to give a very brief introduction about the St. Laboratory. And this lab has history of almost 81 years. And last year we celebrated the 80th anniversary of the lab. And it was established in 1938, utilizing the 50 feet of water drop of the waterfall, as you can see. Okay? And it has been a lab of water for 80 years. Okay? So it diverted a part of the Mississippi River to let 2,200 gallons of water for every second to run through the building and to do all kinds of experiments. And the lab has developed into a multidisciplinary research institute focused on fluid flows related to environmental, energy, and other area of engineering and geoscience research. And so for this building, well, the top floor is the wind tunnel, and this is the third floor, and then go down the model floor and main channel, and all the way to the basement. And by the way, at this moment, the basement is flooded, and that is by design. And well, just to check, it still has more than 1 feet of water. And actually, a few weeks ago, one of our research associate, Dr. Jessica Kozarek, she actually used the kayak to maneuver around the basement for that. So, well, okay. So the lab now has 35 research and administrative staff members, and it also has now 16 or 17 actually faculty members from 5 different departments and 2 colleges from the university. And it has been doing all kinds of research related to flows and geosciences happening in nature. Okay, and so I just want to welcome you here, and I know this is a very special event, and I'm very glad to have you here, and I hope to see you more in the lab in the future. And next, I'm going to give the microphone to Director of Water Resources Center of University of Minnesota.
Thanks a lot, Lian. For those of you who don't know me, Jeff Peterson, Director of the Water Resources Center here. And I'm really happy and excited to be able to add my welcome to this is the inaugural event in the Minnesota Stormwater Seminar Series. The seminar series, as some of you may know already, is part of a larger program that we're calling the Minnesota Stormwater Research and Technology Transfer Program. It is made possible in large part by an appropriation from the Minnesota Clean Water Fund that has really accelerated this work. But it's also really been driven along, I guess I would say the engine that's really driving it along is the Minnesota Stormwater Research Council, which I see many members of sitting in the audience here. The council and its member organizations have actually contributed matching funds to this program to the tune of over $200,000 so far. So that's really tremendous. So the program is administered by the Water Resources Center, but we do it in collaboration with the Minnesota Stormwater Research Council. They play a big role in setting the agenda and identifying and evaluating the projects that we fund. As the name of the program suggests, it has sort of 2 main thrusts or goals. So one of them is to advance stormwater research and to do it in a way that develops the next generation of tools and technologies that'll manage runoff in built environments while protecting water quality. We've got a lot of you may be familiar with some of the research projects that have been funded through that program. In fact, it's might not be unlikely that some of you here or tuning in online are involved in one of those projects. There's, I think, 11 active projects that have been funded that involve 50 scientists in Minnesota. So quite a community developed now. The other aspect of the program is technology transfer. And the idea behind that, of course, is to get the results of the research into the hands of the people who need it and who can use it and move it along toward implementation. So to bring it to practitioners and engineers and managers and policymakers. actually, a lot of the research projects have a technology transfer component built into them. So there's work embedded in those projects that will move those specific topics hopefully closer to implementation. But as sort of one of the overarching technology transfer activities is this seminar series right here. And we're so pleased to be able to collaborate with the St. Anthony Falls Laboratory on this. They'll be hosting, I think, this and the future seminars, and John Gulliver and Andy Erickson over there put a lot of thought and work into planning this. They've been working with John Bellata in our center, who is traveling, otherwise he would be here today as well. They have a schedule charted out all the way until June 2020, I believe, and if funding continues and things go well, I expect we'll continue it beyond that. If you're here, that probably means you're on an email list somewhere that you're going to get notified of future events, so you will hear about those. If you want more information about the overall program, couple of things. It's on our website, the Water Resources Center website. We'll send you, John Bellata tells me he's planning to send links to that to everybody on the who's attending today. One of the things that's going to be posted on our website later this week is this update. This is like a 4-page brochure here that highlights some of the recent work and the ongoing projects. This is actually a sneak peek for those of you who are in the room. It won't be released on the website until later in the week, but I'll put the printed copies over here. So if you want the sneak peek, you can grab it on your way out. So again, welcome. We're delighted to help launch this series. We're especially excited that Bill Hunt is the first speaker. And toward that end, I will turn it over to John Gulliver to introduce Bill Hunt. Thank you.
Thank you.
So 2 welcomes and 1 introduction. I'll try and be brief. But I have some writing here. I have to look at the paper. Dr. William F. Hunt III.
Yeah.
Is a William Neal Reynolds Distinguished University Professor and Extension Specialist in North Carolina State University's Department of Biological and Agricultural Engineering. Bill has 2 bachelor's degrees from NCSU, 1 in civil engineering and 1 in economics. He has 1 master's from NCSU in biological and ag engineering, and he has a PhD from Penn State in agricultural and biological engineering. They call themselves, I guess, the ABE.
ABE. Like honest.
Abby, the Abby department.
Yeah.
So since 2000, Bill has assisted with design, installation, and monitoring of over 150 stormwater control measures, including bioretention, stormwater wetlands, innovative wet ponds, the whole list. Many of you know it. He teaches, and this shocked me, 20 to 25 short courses and workshops each year on stormwater design across the United States. That's a lot of workshops. Bill, today he's going to give us a talk on adaptation of extreme events, which we are seeing more of these days. And Bill, you are a distinguished SAFL seminar speaker and a stormwater seminar speaker today, which is a distinguished position. So I would say you are doubly distinguished. I give you Bill Hunt.
Thank you. It is my great pleasure to be here. And then when Andy and John told me, it's like, yeah, you're going to be the first one. I said, dude, I better bring my A game. So A game. So I put a little effort into this. I'm excited to talk about it because I don't want to fall flat on my face with what, about 80 people in the room and 6,000 or 7,000 people watching online. I heard because I got 5 emails myself about I'm speaking in Minnesota. I'm like, yeah, it's working. It's working. You're getting out. My department head knew. I'm like, that's right. That's right. He says, that's good, Bill. I said, thanks. Okay. So it is great to be back in, this is going to be a long presentation. All right. All right, let's try again. Boom. It's great to be back in Minnesota. I love coming up here. Did you guess last time I was here was even warmer than it is today? And Andy Erickson is such a representative of the travel. It's like an ambassador for the state. And like, Andy, what should I do? I'm going to bring my kids up. He says, oh, you got to go fishing. All right, so I did. And I was so tickled to pull in Northern Pike. That was incredible. And then for me, what I wanted to do more than anything is visit what? What is that? That's right, the start of the Mississippi River. I love telling people I walked across the Mississippi River. Like what bridge? No, not the bridge, like in the water. Like, you nuts? So no, it's up in Minnesota. It's awesome. Okay, so the genesis of this presentation, so it's great to be back. That's why I really, you guys are so, or shall I say, y'all are so lucky up here to have the University of Minnesota and such great folks both on the research and the extension end. See John Chapman up here, but you guys have just do great work, and you're so blessed as a state to have the university doing the work that it is doing. All right, so you can give those guys a round of applause. Just give them a round of applause right now. That's right. And so I love coming up, and this is such a huge, it's just a huge blessing to be up to come here today. I'll tell you just really briefly about my state, because like every Minnesotan I've ever met, they love Minnesota. Like, it's just shocking. Like, they love Minnesota, right? And I feel that way about my state, North Carolina. I was born there. I've grown up there. I left to go to finish my schooling, but it's one of the 10 most populous states. In fact, it's number 9. In fact, we just passed Michigan by. It's also one of the fastest growing, and we get a fair amount of rain over the course of the year. And we have a beautiful mountains. Beautiful mountains. We have good cold. It snows up there even, right? I know y'all know a whole lot more about snow than I do, but it does snow up there. If you take a look, these are my children climbing up the rocks. I have been told I'm a free-range parent. I'm kind of proud of that, okay? And then we also have beautiful coastlines. If you've ever been to North Carolina, our beaches are really stunning. They're beautiful, particularly the northern Outer Banks. And this is one of my children swimming. And over here is a shipwreck. You might not know, but there's more ships wrecked off the coast of North Carolina than I think every state but Florida and California in the United States. It's called the Graveyard of the Atlantic. It's a really interesting place to go. You can actually swim out to them. All right, and then last but not least, how many folks here are students? Great, that's a lot of you. I'm gonna come back to some of the points on this slide in just a bit, but the most important people, I travel overseas, like what's the most important thing that ever happened in your state? And the answer is easy, it's easy. The first heavier than air flight occurred in North Carolina in the Outer Banks. Some people from Ohio try to claim it. I don't get it. You know, they can say they were the conception of aviation, but the birthplace really was where the flight occurred, which is, of course, in North Carolina. It's a beautiful place. If you've never been there, it's a beautiful place to go visit, all right? But I'm going to come back to this at the very end, so it was important for me to mention that. Now let's talk about hurricanes, and because we got hit by a big one. All right, now, and this is my dad, all right? My father is talking to Lady Godiva. She did keep all her clothes on, thank God. And he's the type, and this is, I'm totally from this man right here. Loves to talk to people, but he would always like to talk about Hurricane Hazel, all right? That was his generational storm. And I remember growing up, and he talked about Hazel and about seeing boats on their side and knocking houses over. And he talked about how it just cleared out entire islands off the coast of North Carolina. It was our generational storm, all right? And so I waited for a while for my generational storm, but the real take-home part of this presentation is that I've had a lot of generational storms, all right? He had one, I've had a lot. Now, none of you here, hopefully, have ever had to live, I should say, maybe some of you had, you don't really want to be living through a hurricane. The first time one big one comes, it's awesome. And then it actually wreaks havoc. And then you're like, okay, stay out. Just give us a little brush. Like, they are good for rainfall data. And so I love getting stormwater data from storms that hit Florida. Sorry, Floridians are watching here, that find their way up. And by the time they're kind of tired and only dump about 3 inches of rain, that's a great thing for me as a stormwater monitoring specialist, okay? But when they hit you hard, it is kind of nasty when it hits North Carolina. North Carolina, by the way, is the #2 state in America for hurricane strikes, trailing only Florida. North Carolina and Texas do a duel to see who gets hit more in terms of #2 and versus #3. All right, but high winds, storm surge, and then heavy rains. And when you get those 3 things, those other 4 things that are all kind of awful happen. All right, and I'm going to talk about some of those as we go through. The first thing I want to mention, everybody, is when you turn on the TV and you see a storm is category 4, which is pretty bad on a scale of 1 to 5, they're strictly referring to its wind speed. All right, and while wind speed does have an impact, a major impact on the type of destruction that a hurricane brings to you, it does not tell the whole story. So that's going to be one of the other take-home points I'm going to share with you, all right? And what they mean by a wind speed of that is a sustained wind of at least 1 minute of that. And if you bring this back to miles per hour, we're talking about 76 miles per hour. And I think this is like 180 or something. Long story short, it's really high. These are really, really high winds, all right? And so when this was coming on, I was over here on my sabbatical, and I had some friends that live along the North Carolina coast, and they were calling me when the storm was like way out here. And they're like, hey, Bill, by the time you get back, we're going to get hit by a hurricane. I'm like, uh-huh. And it's monstrous. I'm like, uh-huh. I said, where is it right now? Well, it's somewhere between the Azores. I'm like, stop right there. It really doesn't matter. But they're predicting it. It's so far away, it doesn't really matter. And then I was flying back over the Atlantic to come back home with my children. And I started thinking about, it was the hurricane was somewhere in here at that point. I started thinking about the name of the storm, again with an F, as in the name was Florence. I started thinking about some of these other names that had hit North Carolina in my lifetime: Hurricane Fran, Hurricane Floyd. Those are the 2 worst storms I had seen. I'm like, oh, another F storm. This might actually hit our state. And that's when I began to take it pretty seriously. But so this is going to be our first cut. All right, so we're gonna escape from this. Maybe I can do it. All right, I'm gonna escape from this. All right, and we're gonna show this video. But you know, can we go back? I just made a mistake. It won't be the first time that happens. Yes, please. All right, so I will point out that can we go? Oh, I can do that. Boom. If you take a look here, so the reds are worse. It gets lighter color. So by the time it hit North Carolina, it had gotten down to category 1. All right. And so all these people that were talking about, one thing about hurricanes is nice is you get a lot of outpouring of affection from colleagues from all over the world. Oh, we see you're about to hit by a hurricane. Hope you're doing okay. You know, we were fine. So by the time it hit, it had gotten down to category 1. All right. And so the love and outpouring of affection had stopped because, oh, it's just a category 1. Okay. And then, boom. And then it didn't help that stuff like this was happening, all right? So we'll hit the play button. And this guy's out there. He's talking about how bad the wind is. And then these guys are just walking like it's nothing, right? By the way, it used to be a very crisp recording. You know, I'm like, you're really giving the hurricane a bad name. No one's going to take this storm seriously. Great job, by the way. Thanks. We'll pop back to the PowerPoint. By the way, I really appreciate your help. Okay, so... But there were some problems, all right? There were some problems, like this stuff, all right? I mean, there's homes are blown apart, or pieces of homes are blown apart. This is near my house. I'm 130 miles inland from where the storm hit, and I can promise you that person has a new deck. It's brand new. Some of your insurance dollars have gone to buy that person a new deck. Now, and so, but all that, you know, it's going to happen. Some trees fall. You have trees fall here, right? And it did happen, but it was category 1, so it wasn't as bad. But yet, even with something that was not as bad, Florence topples tree, kills mother and infant. That's a real event. That's a family whose life has been forever changed because of a storm whose first name is Florence. All right. You know, you just had me laugh, and now you brought me back. I'm sorry. That's the nature of a hurricane. Okay. Now I'm going to talk about storm surge. Now, storm surge is related to winds. And some of you, how many of you have ever done this? Like you just sit there and just kind of watch the little spin job. One of my bucket lists, you know, Dr. Gulliver and I like to exchange travel stories because Dr. Gulliver travels a little bit more than I do, and I love traveling. And so this is one of my bucket list items, is to go to the equator. Because you know what happens when you go south of the equator? The spin goes the other way. For real. And so they say that if you're staying on top of the equator, there's no spin. And that is a bucket list of, I mean, like you got some weird bucket list on. I do, that's fine, I'll own it. I've done this standing on either side of the prime meridian. That's kind of an easy one to do. If you go to London, you go to Greenwich, and you can stand in both hemispheres. It's kind of cool. There's a line that goes right through your legs. Last year, I went to the Arctic Circle, and I stood on the Arctic Circle. That was kind of cool, right? But this one, that's a big one. The equator with the water. So anyway, you see that spinning? That happens not just in your tub, but it happens in nature, like all your tornadoes, right? And also hurricanes. All right, so here's Hurricane Florence. It is spinning towards the coast of North Carolina. And I want you to think about the high winds, like 100 mile per hour, 120 mile per hour winds that are blowing all on the north side of this eye, all right? So it's winds pushing. Y'all, when you design stuff for your lakes, I'm sure you look at the reach of the lake. What's the word? There's a word for it. The fetch. Thank you. Yeah, great. The fetch of the lake, and you make. Well, imagine the fetch. It's the Atlantic Ocean, right? And winds are blowing. And as a result, it pushes a lot of water on land. And I have a video here, but we're not going to show this particular one. But you can imagine this wall of water that's been tilted up somewhere to the tune of about 8 feet. And that was low because this storm ended up being a Cat 1. It could have been a lot worse. They're predicting a lot worse. But this blows past and just knocks buildings down, all right? And then it gets even more interesting because the wind was blowing in this direction, all right? Water starts getting pushed up about 45 miles. 45 miles inland to Newbern. All right, so you're pretty far in, and you can see basically the water that got pushed up into these communities. And the best way to look at it is what got left. All right, the boat did not show up there mysteriously. That is a boat from a river that's been pushed way up inland due totally to storm surge, due to the fact that the wind is blowing that water and pushing it up. And so that's the other realm of damage that happens. And then the last one, and this is the one that's generally the focus of this particular talk, is rain. And these are, for example, we do a lot of work across the state. We're North Carolina State University, which means we do work across our state. And we have a decent number of projects that are along the coast and in the southern part of our state, southeastern part of the state. And this is where the hurricane came across. All those are impacted. You can see a couple of them, all right? There was a research site here, and it disappeared. This was a picture sent to me by someone who knows that I care. This is my picture. This is a picture from I-40. We did a nice research project along here. That's what it looked like right after the storm event, after it had been shut down, okay? Which gets us to this next very important thing, thanks to my good friend, is that I looked at this, and I'm like, you have got to be kidding. You're about to see something. I think it's this is not as funny necessarily. We'll hit the play button here. By the way, thanks so much for helping me out. Yeah, you got, wow, okay, that's fine. It's moving fast. That's fine. It's going to be going. All right. So what you see here is Interstate 40. It's not a river. It's not a river. It's Interstate 40. And when I saw this particular video really shook me, because when I studied civil engineering and I studied hydraulics under Dr. Rooney Malcolm, who, John, you had Dr. Malcolm, I remember him telling us that you design interstate culverts for 500-year storms. And I'm like, that wasn't just a culvert failure, right? This is big. Something big, really, and this is when it happened, when I saw this, this is really, thank you so very much. This is really when I realized we had issues. For example, all right, that stretch of road, this is an apocalyptic picture, right? They had, I don't know if you saw this, but they had the firemen out there, and they're like, firefighters, they're out there, and they're, just washing the fish off the highway. Just start thinking about that for a second. Okay, that's what happened with this storm event. The state of Virginia sent this text out, and it says, hey, if you're going to North Carolina, don't. The state is shut down. Go to Tennessee. That's essentially what they're saying, right? Avoid travel into the state. Drive to Tennessee. So these are the types of things like, wow, that's a lot of water. In fact, what you see right here, those black dots are road closures that happened on DOT maintained roads. Where's Andrea, MnDOT? There he is. Imagine this happening, Miss Lee. You're like, oh my God, it would really be bad. You would not sleep for weeks. I can promise you, your colleagues in North Carolina, they did, but they didn't sleep much. All right. And by the way, it gets worse because this is September 16th. The storm is still here. The storm then wrapped around and hit western North Carolina. And these black dots here, you saw even more black dots up in here. Basically, the entire southern tier of North Carolina was shut down by one storm. By one storm. It's big. And that's the other thing. That's, oh, the storm came ashore in Wrightsville Beach. Well, when the storm comes ashore in Wrightsville Beach, it's essentially impacting 2 states worth of coastlines. They're pretty phenomenal events. All right. And keep in mind, when I'm watching them, I'm up here in a relative zone of safety. We get hit, trees fall down. There are issues, but it's nothing like typically what happens at and near the coast. Now, what was particularly interesting for me was Wilmington. A couple of friends. One of my friends chose to stay there. The other one got out of Dodge. And Wilmington became an island because remember those black dots I showed you earlier? Every single road that came into Wilmington was shut down, was flooded out. And they had to airlift supplies. It was almost like a little mini Berlin Wall type of situation going on. All right, but caused by weather. All right. And this is example one of the projects we had built a year earlier, and then it's somewhere in here, okay? And that's the least of our problems. But I started paying attention to this because I had my friends down there. I was concerned about their safety. And at this point, this is taken from the news station in Raleigh, but at that point, they had 24 inches, and ended up getting about 26 inches of rain in 4 days. So, we were talking about Atlas 14. I was so excited because for those of you that don't know what that is, you're about to see the beauty of Atlas 14. Let me tell you how good Atlas 14 is. When I was in Spain, I was talking to the guy that was hosting me when I was on my sabbatical. He's like, yeah, we love your weather data. It's awesome. He said, we use it here. And I'm like, oh, he's like, no, we like, when we design stormwater practices, we use your weather data because it's so good. Okay, right? So anyway, we're going to go to Wilmington right now. And for those of you who don't know, I'm going to give you a very quick, short course, all right? This doesn't count as one of my 25 per year, okay? So these basically says the frequency that storms occur. This green line, it's a bit of a misnomer. It says 1, but it's really like 1.01 year. So the likelihood of a storm happening roughly once a year is on that green line. That's the likelihood. And then if you go all the way to this gray line at the top, this is the likelihood of the storm occurs once in 1,000 years, okay? Once in 1,000 year likelihood of occurrence. And I'm going to show you where our storm, by the way, I have converted these to metric units. I will tell you, I will speak English units for you, okay? Our storm, but it doesn't really matter what the units are. That's our storm in Wilmington. That is something to the tune. I think you said Rochester men had a 2001 or 2000 year event. That's what this storm was for Wilmington, North Carolina. They're like, wow, that's pretty amazing. I guess that's why the road shut down, right? They shut down. It wasn't the worst. It wasn't the worst. Wilmington was pretty bad, but all these places here are worse, okay? Wilmington was pretty bad. That honor, the worst, goes to Elizabethtown, and you're ready to see where Elizabethtown. This is where Elizabethtown was. There it is. It's up, 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 up. You've got to be kidding me. That's like 36 inches of rain in 4 days. I meant to look, but I believe that is your annual rainfall. Okay? They got it in 4 days. This is and by the way, you basically graph it out and you try to figure out where it is. This is roughly 1.5 million year event. I mean, who really knows, right? But if you do the graph, like, okay, that's about 1.5 million years. Okay, so it's pretty big, all right? And so just to take this home, that we know that hurricanes, while they are only assessed by wind, so it was a category 1, it was, North Carolina, South Carolina got lucky. We didn't get lucky. We got obliterated by rain, and because they're only rated on wind. And one of the things that I know both the previous governor and then this current governor have both mentioned is maybe, and this is something I have been promoting with their associates, and it hasn't happened, at least the governors have spoken this, of having basically having the National Weather Service, the National Hurricane Center, rate them for two ways. Basically, category 4/3. So, or category 1/5, meaning category 1 from a wind perspective, category 5 or category 4 due to rainfall and flooding potential. Because while they couldn't have done this so easily 20 years ago, they will tell you how fast these storms move. They predicted exactly what was going to happen. They didn't quite get 26 inches, but they said epic rains, at least 10, 15 inches. All right. They may not, and that's an epic rain. So they can get this right. It's time talking about things that can change. One of the things that we can change is we can change how we actually assess hurricanes and how we rate them so people get a better idea. And because they affect such a big, look at this. I mean, it's hitting Richmond and it's about to hit Charleston, South Carolina at the same time. That's probably almost as big as Minnesota. Minnesota's a big state. I get that, right? But this is a big cross section of the country this storm hit, and for parts of the storm, they got soaked, and they got soaked to the point that it was it killed people, and it killed a lot of animals. And frankly, we're lucky it didn't kill hundreds of thousands of animals. The only reason that didn't happen is because we had gotten another hurricane a little while ago, well, about 20 years ago, that did. Okay, and so remember talking about catastrophes in the seminar, we had a catastrophe from another flood perspective on animals, since we made changes for animals, all right? But still, this storm was a killer, all right? But here's the thing. As you might say, everything I just showed you, the roads being shut down, cities becoming islands, you might think that, well, there you go, you just got to have your generational storm. Except the problem is that there have been other storms. You can look at these years, right? This happens to be at one place in North Carolina, but all of these have been since I've been in grad school, all right? It wasn't the generational storm. I thought Hurricane Floyd, when it hit Woodby, it hit Wilmington, and this is what Hurricane Florence did to Wilmington. That's what Hurricane Floyd did to Wilmington. That's how much rain it put on Wilmington. Now, this is 19 years separation, and you're looking at 2 storms with a likelihood of recurrence of 1 in 1,000 years, happening in a 19-year window. 2 of them, all right? And we can keep going. Then there's Hurricane Matthew, which by the way was only 2 years previous to Hurricane Florence and caused widespread flooding. And in a place like Goldsboro, which wasn't the hardest hit, but I just knew because I'd done some projects there. So this is Hurricane Floyd, that's a 1 in 500 year. This is Hurricane Matthew, that's a 1 in 100 year. This is Hurricane Florence, that's a 1 in 200. Okay, so you're telling me is this spot in North Carolina, for example, over the course of a 19-year window, had at least 3 events that would have a likelihood of occurrence of at least 1 in 100 years. Now, I have an asterisk. Every time you see asterisk, you know that something's up, right? That's based upon old data. By the way, that old data is Atlas 14 data. So the first time I gave this presentation, I did it before the North Carolina chapter of the American Public Works Association, which essentially is our stormwater group, all right? They're the ones that convene, they do our stormwater conference. And I had everybody in the room raise their hands if they were from Eastern North Carolina, all right? About a quarter of the room did. I said, okay, I want every one of you to leave your hand up if you believe in these curves. And every single hand went down. And those hands included people that were Democrat, people that were Republican, and people that were independent. Every hand went down. Okay, so there is agreement that what we're using is not right. The previous year I spoke, the previous year there at the same conference, they had the most respected person in the Raleigh-Durham area talk, and he was a climate skeptic. He talked about his journey to believing in climate change. And what I tell people is you can keep those monikers to your, you keep them, I don't care. I'm not going to talk about climate change. I'm going to talk about what our climate is right now. You don't have to worry about changing. I just showed you real data that just occurred over the course of the last 19, well now 20 years. All right, we have a climate now problem, all right? And it gets worse / better. It's not just North Carolina, because the year before we had Hurricane Florence, Hurricane Harvey slammed into Houston and dumped 40 inches of rain. It was the probable maximum flood. I remember calling some buddies up because, look, I'm a nerdy hydrologic engineer. Like, oh my God, Houston just got the PMF. I didn't know it would really happen. That's incredible. And then I needed to wait 1 year, and then we had our very own. That's North America. Yet another, I love this one, yet another typhoon is heading towards Shanghai. I was outside Shanghai before one that came in July hit, and I had to leave. It was interesting being in another country trying to get, like, you got to get out of there. There's a typhoon coming, right? And, you know, they weren't really caring. It was interesting. Like, I'm out of here. Got out, flew out, and I was happy. Another one came, hit it. This is just a cool picture. I mean, but one hit Hong Kong. And then this, the rain in Spain from a hurricane. They didn't teach us that one, right? Oh, and next time you go visit the tropical islands, try to make sure you're not there when a hurricane hits. Wait, Ireland's a tropical island? Look at it. I actually had a buddy that was there. I said, Jason, what was it like? It was like being in a hurricane. I'm like, Jason, because it was. It's not a North Carolina phenomenon. It's not a southeastern US phenomenon. It's all over the globe. All right, places are getting these storms that they didn't get them. And now there's massive amounts of rain that they have to start designing for. So the real question is, and this is what the seminar was about, and I had to be careful not to give up too much of what I wanted to say in here, but what really are we going to do about it? All right, and I want how many of y'all are engineers? That's a great number of you. A lot of you are probably studying things like landscape architecture or landscape architects, and you have your own code of basically a professional behavior, right, that you have to follow. Now, I just showed you a whole bunch of data. Engineers should always be data-driven people. All right, I just showed you a whole bunch of data. This is what the Code of Ethics says for engineers, and I'm going to read it to you. Engineering is an important and learned profession. As members of this profession, engineers are expected to exhibit the highest standards of honesty and integrity. Engineering has a direct and vital impact on the quality of life for all people. Accordingly, the services provided by engineers require honesty, impartiality, fairness, and equity, and must be dedicated to the protection of the public health, safety, and welfare. Engineers must perform under a standard of professional behavior that requires adherence to the highest principles of ethical conduct. The fundamental canon number 1, engineers must or shall hold paramount the safety, health, and welfare of the public. Now, I would challenge any engineer who practices in the Wilmington area or the Fayetteville area of North Carolina to argue to my face that designing based upon the current Atlas numbers is actually protecting the public's health, safety, and welfare. Because it's not. And so this is therefore an opportunity for our profession to do something it does not like to do. And it's to make noise. We usually don't like making noise. We let other people do noise. I don't want to state, and Jonathan's from Chapel Hill over here in Chapel Hill, But we didn't do protests. We're like, dude, let them do the protests. We're just going to put our head down and get this statics problem right, okay? But maybe it's time for us, we have the data, to actually stand up and make people who make decisions aware of the fact that we are not using appropriate design standards. We're not. The data back me up. So now, back us up. So now thinking about green infrastructure, how does all this relate to green infrastructure? Well, first off, people, and we talked about this before, people said, well, let's just build our stormwater control measures to help out, right? And so can you design stormwater control measures to actually help out with stuff like this? Well, this is, and Vinny Taguchi's here. I looked, but your data did not, the picture I could get from you did not illustrate the point. But downspout destination, he did a paper for us before he came up here. But this looked at the impact of downspout disconnects on runoff volume mitigation, all right? And what you're seeing here, the black line, is the median storm event. Well, guess what these numbers are down here? Those are the big storms. So the stormwater control measure, it's a very simple one, but it illustrates my point. The stormwater control, it does great on that 0.45 incher. Fantastic. And we're not talking 18, by the way, inches. We're talking like 3 inches, 2 inches. It's not doing, it's a little bit, but not a whole lot. All right. So stormwater control measures, if you think about how they are designed, they basically do a good job of treating moderately sized events. From roughly 1 inch to 1.5 inches, that's how we design them. And they do a good job of it, okay? We think about conserving space with them, and then we make sure that they convey the larger storm events. So really, what does climate change or climate now mean for us from a stormwater control measure standpoint? It means we got to probably make them a little bit bigger and make them a little bit more robust. All right? But we're not. The stormwater control measure, the idea that you can take a stormwater control measure and actually, quote, fix, because we've been trained to fix things, right? The idea that you can take a storm and you can fix 22 inches of rain, no SCM's going to do that. At least no SCM that people are willing to pay for, all right? The bigger decision that to me comes out of this is, where are you going to let folks develop? And I am a market guy. I think I'm one of a dying breed of professors that does believe in the power of the market. Capitalism, okay? But I'm going to tell you, this is one of the places that I don't know if capitalism will get things right in the short term, okay? A country that does things a little differently than we do, what they've done with their water courses, and they're like, you're not building near here. Because when it floods, we don't want to deal with the mess. All right, so you're going to put your buildings a little further afield. All right, here's another example. I mean, there's the buildings. Here's where, and this is an ag field out here. This is where we're going to get flooded. That's a solution. All right, you can keep the, you can use that for recreational purposes. Right, here is passive recreation in floodplains. And by the way, this is not stuff that we don't do here already. I'm pretty sure you guys have a Mississippi River walk. Yeah, right. Because I vaguely remember walking it at one point. I don't think it was right near SAFL though. No, it's fine, doesn't matter. But the point is that we do this. Maybe we just need to do more of this, all right? Maybe you dedicate, and this is one of the things that my hydraulics engineer, or my hydrologic engineering professor talked about. He says, in the floodplain, you guys should just put soccer fields. Because you know, when it floods, kids just won't play soccer. No big deal, right? We can do, or he called them ball fields, because back in the 90s, not everybody was playing soccer. And then maybe you can have urban ag. This is where my department, biological engineering, comes in. Maybe you dedicate these wide swaths. Look, we're talking about urban ag all the time anymore, right? That's one of the new things. Well, you know what? We might be able to do that new thing in the same spot that every so often is going to get flooded. Okay, the question really is, and I think I'll ask, is what really is every so often? You can't see that. Those are my children just jumping into rivers. They love that, okay? larger storms certainly do appear to be getting more numerous. It's been proven that there's more typhoons in the Pacific Basin than there has been in the past. In the Atlantic, the number, I don't think, I haven't seen a study that says the number has changed, but I do know that the impacts of them have gotten worse, and they're striking places that normally don't get hit. Spain, Ireland, as 2 examples, okay? If we're going to design for stormwater practices, we have to account for the new reality of rain. What does that mean? It means maybe the practices are going to get a little bit bigger, a little bit stronger. But really, really, what we need to think about is protecting people from flood. And this is where the hard decisions are going to reside. Because basically what we're saying is, guys, we don't know. You could use this as a flood of record. We talked about that in the seminar. You could say, here's where the flood of record was. And from now on in the flood of record, we're going to allow no new development. You could do that. I promise you there's pushback. Because that land that was getting flooded is valuable. Now there is, and I saved this from the seminar for this, I believe there is one silver bullet out there, is that in the end, someone pays, okay? And I believe that the insurance industry, if they can be made to understand what, and there's a lot of smart people in the insurance industry. A lot of people really good at math have gotten into the insurance industry. If they can understand that the risks have changed, which again gets to this idea of opening up the conversation, the social contract. Insurance is a part of the social contract, okay? If they can understand that investments they make are more likely now to fail, then they might make some decisions and step away and say, I don't think we want to insure this. In the end, there probably will always be somebody, all right? The other thing is the federal government doesn't have to go in, and we truly have properties that have received federal subsidies 13 times. 13 times from big storms. Because not just big strikes, but passing brushes. Remember, we're number 2 in the country for hurricane strikes. So passing brushes are flooding properties out. They may not be, the government may only be spending a couple grand, but 13 times, I'm sorry, and I appreciate that it's my family's homestead. I appreciate that, but there does come a point where like, no. We got to make a decision, a difficult decision, but we cannot pay you to stay in a place that we are almost guaranteed to have to pay you again. We can make better decisions, and the people in this room are among those. Because in the end, we have to protect the health, safety, and welfare of our public. That to me is what drives me in the decisions that decisions I make in terms of what I like to lecture about and tell people. This is a huge one, which gets me to remember I promised you I'd come back. Now, someone I just shared with you might sound like it's going to be really hard to do. I get that. 116 years ago, there were a couple of brothers who did something that wasn't considered really hard to do. People thought it was impossible. They thought it was impossible. That to put a heavier than air, many people did, a heavier than air craft up in the air was impossible. But the reality is it wasn't. And there are people who are depending on us to do the right thing. They're depending upon us to make decisions now that enables them to live a little more securely in the next 15 to 20 years. And it's to the students and it's to the professionals here that I challenge you with that. And so with that, I will stop my presentation. Thank you so much for your attention.
So what sort of questions do you have for Bill?
Randy, I hope I lived up to your hype. I saw your email too. Randy said I was, quote, the real deal. I said, oh my God. And I appreciate that.
Questions from online? Okay, here you are, Andy.
I'm amazed at this room. So when it comes to new design standards, regulations, whatever we're going to call them, there's this interesting question of scale. So it's not going to, those new standards aren't going to come at the project level.
That's right.
They're virtually impossible to do at the city level. Maybe you can do them at a state level. Best of all possible worlds, federal. Can you talk a bit about that?
Yeah, I personally think, honestly, I'm gonna go back to the panel. I really loved the panel. Where's Andy? I don't know if you and Andy put together. I thought it was a great panel you put together. I love speaking with the ladies. They had some incredibly insightful ideas. And I think one of the things that was pointed out was that there is opportunity at the local level. I think Liz talked about that actually quite eloquently. There are opportunities at the local level to make decisions. What I think most of the, I think most decisions though can be made at the state level. I really do. I actually do not think, and I wasn't, when I was in England, I gave a talk, it wasn't as detailed as this, but as soon as I was done, I had the first question sunken up. It was like, I got 2 words for you, Donald Trump. And I'm like, doesn't matter. I mean, it does, but it doesn't matter. I said, our state can make the decisions to protect people by forcing new development to stay out of more likely flood-prone areas. And flood-prone areas that are not marked on the map. All right, floodplains above and beyond. Erin talked about looking at the 500-year floodplain and letting that sort of be a surrogate for the 100-year. Those are the types of decisions that can be made at the state level. The issue, of course, is that there's a second market that's driving it, and it's people that own land that want to develop the land, and the closer you get to the water, the more valuable that land is. And I understand it. I understand that that's an issue. But at some point, we're going to have to, we say in the South, have a come to Jesus meeting. I don't know if y'all say that here. We have to have a come to Jesus meeting, and it needs to be ironed out. And currently, we have a governor that is trying to do that. And I will say one more thing on the whole political front, as far as statewide. About 2/3 of the elected officials from the area that was hit are Republican. 2/3 of 3/4. And trust me, they want to fix it too. Because it is a disaster that hits every person, every creed, every color. Everyone was hit by this. Everyone was impacted by it. It's not a white man's problem. It's not a poor person. It is everybody's problem. All right? And because of that, political officials from across the spectrum are in unity of trying to fix it. Now, what the solutions are, obviously, is going to be interesting because there's going to be some haranguing, I'm sure, and haggling associated with that. But there is a consensus to fix it among both parties. And for that, I am very, very optimistic. Okay, yes.
So during the seminar, I referenced our city engineer conference we have every year in January. We had the extreme storm presentation. I suspect this year, every so often, we have a futurist. So I want to ask you, what do you really see? What's it going to be like in 30 years from now? Are there going to be cities and or states that have been more progressive, and are they going to be more attractive because there are going to be other city states that are a little bit more derelict? Because
absolutely,
if you look at the trend in billions of dollars spent in disaster recovery and all the other pressures for federal government money just on regular infrastructure, there's money's going to run out. It just isn't going to be enough to start fixing all this stuff that from the disasters. So what do you think is going to happen in the year 20?
That's a great question. I like to scroll through the news items every day. I don't listen or watch the news, but I do read it. And I went through, and they had USA Today ranked they had the fastest growing city in every state. Okay. In Minnesota, specifically, it was coming up here, it's Minneapolis. In North Carolina, it's Raleigh. Okay, 2 state capitals, also university towns. NC State is in Raleigh, and obviously U of M is here in Minneapolis and in St. Paul. Minneapolis, though, was the fastest growing city. In Kansas, the fastest growing city was Lawrence. In Illinois, the fastest growing metropolitan area, it was actually done by metropolitan area, was Urbana-Champaign. In Ohio, the fastest growing city was Columbus, it's capital city and a university town. The fastest growing city in Vermont was Burlington. And I can keep going. I think you see where I'm going here. That places that are willing to make infrastructural improvements, are willing to make those investments, are going to be the more attractive places to live. That's where people are going for work, all right? And I have a very real concern in that, you know, what is sort of an urban-rural divide is only gonna get worse because infrastructural improvements are being made in places that remain or become even more affluent, so they have a bigger tax base to draw upon, and they make the smart investment, whereas places that aren't doing enough right now lose more of their brain power and are left with smaller tax bases. They don't want to, typically those places don't want to pay as much taxes anyway, and they will continue to be further left behind. Honestly, I don't see a fix to that in the United States of America. I don't. I have been places where I was in the UK. I lived in the UK. I lived in a United States. They have bigger cities closer together. It's, I think, 5 times more densely populated than North Carolina than it is in England and North Carolina 6 times. All right. So because you have big cities, you have people living in rural communities actually working in the big cities. You don't see this population range from rural Britain that you do see to some extent from rural America. And honestly, I have more hope for them that people who are living in rural areas can also make good decisions based upon smaller jurisdictions, but honestly, rural affluence on a capital basis in those communities. Now, I actually could see their rural communities coming through this a lot of it better. But I say this with also my heart that there are many elements of rural America that a lot of us that cities, I really do. The idea of going out and exploring and understanding nature better. You know, my kids in my department have grown up on a farm or they're confident outside. They appreciate the outdoors. There's so many things in rural America that I really want to see propagated and continue as part of our national identity. And yet, because of this investment difference that people want to move, I'm really worried about it. I know it's a little bit of a bleak thing, but it's a call to. I can do it.
No, you have to use my phone for online.
Okay, sorry. So just a quick question. You showed the curves that are based on a recurrence interval for these storms. And in our part of the world here, so speaking of rural areas, I have a group of students here from Minnesota State and Mankato. So we're up here to see you guys talk. And one of the things down there is that our rivers are flooding more frequently. We know that. We have pretty good data to show that. But when we're asked by the city to try to prove that point and tell them what to do, they have flood control walls all up and down the river, many cities, these small towns. How do we present data to them when they want to see a recurrence interval statistical analysis when you have a transient statistics that really, it's constantly changing, right? And this has been a problem that's been raking through my mind and others that I work with. You know, it's one thing to go in and say, let's build something for a slightly higher recurrence interval, but what do you tell them? What's the number, right?
And that is a problem. We talked about that a little bit in the when you guys did the and I'm really glad you're here. We had a panel discussion, and that was one of the things that maybe Andrea brought up is that we don't exactly have data. I think all of us expect this. We don't have data to know exactly how it's going to treat. We just fuzzy gray zone, well, it'll probably be somewhere that's a difficult thing. If engineers are really good about it, if you give them numbers to design from, they design problems. That's what they want to know. I heard, just tell me the number. I've heard that one. You've probably heard that before. It's kind of frustrating when you're teaching. Like, oh, what do you think? But just tell me. I know. But the other part of your question was, how do you prove a difference? And the only thing you can do is take a look at long-term trends. And you might try to find it be a line like this, or it may just be sort of pockmarks. When we do the pockmark version, you see, 40 years of bumps around here, and there are some high events in the previous 40 years. But the issue is that in the last 20 years, where we might have a high pockmark once every 10 years beforehand, we have high pockmarks 3 out of every 4 years. And I think that's, if you're trying to show them that it's getting where it doesn't give exactly a design solution, but at least can convince them that, okay, I guess we need to do something a little bit differently. I think my phone.
Hi, thank you for the presentation. My name is Tim. I have a question for you. Timothy. So you have a call to action, and there's folks here that are wondering how they might act. What specifically could they do? So I participate as a professional in codes and standards setting. Generally speaking, in the trades, I focus specifically on landscape irrigation. So codes and standards having to do with the standard of how a product shall be and the code as to how a product shall be installed. What mechanisms exist for professional engineers to set, evaluate, and modify design practices in the engineering fields that somebody might take action on?
Great question. There's a couple of options. One, actually, it's a trio of options. Two of them are very much related. One is that you can get involved with local communities or with the state and encourage stricter stormwater. Basically, if you need a surrogate, say, look, we need to start thinking of the 500-year storm as the 100-year storm. We need to think of what is now called a 100-year storm. It's really the 50-year storm. And there is a way that within local, and we see that in North Carolina, that local jurisdictions, a few of them, University, where Chapel Hill is, for example, which is where the University of North Carolina is, they require more protection of land in and around streams. You can also do that by way of the state government and also going to legislators. And that's one of the things that I have asked our engineers in North Carolina to do, is to talk to legislators, particularly in districts that were impacted by the storm. In fact, a lot of what they told me to do is like, Bill Hunt, that talk I just gave y'all, he says, you need to give that to the legislature. I'm still trying. But there are ways that from a political standpoint, you can get involved in basically informing politicians or going to the state agency and pushing that. Right now, we're doing this through a governor. We have a good avenue that the governor has a consortium of elected officials he's put together at the coast. And so we're able to work through those. We're basically trying to influence those folks in the decision. And then the last thing you can do is work within societies. The American Society of Civil Engineers, for example, is my society. And the other one that in North Carolina has a lot of clout is the American Public Works Association. And it is possible that those societies can issue recommendations, or ASC actually can come up with a white paper or a method of practice. If you're trying to look at how to designing for unknown climate, or in my consideration, the climate now situation, that you need to put into practice these things. And if more of that is done, and once ASCE does that, then the ability, that has a fair amount of clout, and they can go into the state legislature or they can go into Congress and perhaps have some impact. But I'm one of those believers that if you can have a political solution solve it locally, and try not to have the state or the federal government get involved. But this is one of those cases where sometimes you can't just rely on a local. You've got to at least get the state in. It's a good question.
There's one question from online.
Right. So I believe we've already been talking about certain aspects of this, but the question is about, do you believe that cities at the city level will begin restricting development away from floodplains, or will they still be continuing to try to engineer their way out of the project? And they reference a flood wall project in Richmond.
Yeah. Well, the answer is it depends. It depends on the city. In certain cities, I would guess that Minneapolis is probably one of the cities that will be the first to get off the engineer their way out of its solution. And I think it's also going to come as a hybrid, that there's going to be certain places that honestly the land is so valuable that, you know, that the economics of the situation are such that development is still going to happen, places going to flood, and the people that are residing there or working there will just pay hopefully more in insurance. They should. Okay. And then there's going to be other places where city leaders can say, all right, we can draw a line here, a real line. We're not going to develop, you know, within, you know, X number of feet of a stream, or within the 500-year or the 100-year floodplain, or restrict development to non-residential and non-commercial types of land uses. And so I see that hybrid actually probably obviously starting first. Markets are what they are, and land value is what it is. And if the land value is sufficiently high, I mean, you can take a look at who donates to political campaigns. You can. And if those same people that have helped get certain councilors elected, I probably shouldn't be saying this, but it's the fact, and I'm in Minnesota and I'm not in North Carolina right now. Yeah, like, sorry, they're going to hate me now. You know, you can look and see who donates. I mean, everyone here knows what I'm talking about. And if people that want to develop have basically helped bankroll the election of, and it's their right to do this, right, of the majority of the city council, it's probably gonna get developed, right? Yeah. Okay, I don't want to be like an island here. I think we all know this, and and then maybe it's easier for someone from out of state to say it, and I get that totally, I do. So I'm gonna say it on behalf of all of you. Okay. Okay. Great question. Yes, sir.
I just had a quick one to follow up maybe on that. And I've been wondering about the potential roles of insurance companies in all this, because obviously they're sort of adapting to climate now already for various reasons, and in terms of markets and other areas to take action for engineers specifically, but also in general.
I'm really glad you brought that up. I actually believe that the solution, remember, I'm a market guy. I believe that the solution to this is through the insurance companies, because if they can start deeming properties as too risky of an investment, I'm going to talk about a consequence in a second, that they essentially will not fund development in certain zones. That is a way out, but I should say it's a partial way out, because what will eventually happen is you'll just get gentrification, and that is a decision. I know Erin talked about this earlier. She's still here. You know, you start thinking about what's fair for all right? Who can afford to pay really high insurance rates? People who have money. And so land that is developable near water bodies or in potential flood courses, or on the extremity of the flood course. The flood course itself, they're not going to develop, but on that fringe, it may get to the point that it's just simply too expensive for anybody but those who have a lot of money to live there. And that's what will happen when you follow the insurance route, is that in the end, only people that are willing to pay the highest of premiums are going to basically afford to live in places that are more likely flood prone. That if you let the market solution go, in the end, I think that's in the end what happens. Yeah.
Okay, we'll close this now. Let's thank Bill for a nice talk.